Hello, I am Rishika and we are team experts.
And I am Nipun, team leader of the team expert.
Our team ID is 55628. We are presenting a solution for the problem statement ID SIH25022 titled Maximizing Section Throughput Using AI Powered Precise Train Traffic Control. This falls under the transportation and logistics theme under the software category. In the next few minutes, we will walk you through our approach, solution, innovation, and how our system transforms the railway operations. Indian Railways is a vast network system which carries around 24 million passengers and kilos of freight on everyday basis. But behind this vast network lies an unknown struggle, the struggle of the section controllers. These section controllers are the ones who manage the overall train incoming, outgoing, delays, and rerouting on the tracks. But today, due to the manual operations which is done by the system, the overload information, the scattered data, the rerouting issues that they are facing is today important problem. Now let us discuss our problem statement. As I've already mentioned, the train controllers are the backbone of our system who make all the type of real-time decisions such as delaying, rerouting, any sort of proceedings. Due to the rising traffic volumes, there is an issue with punctuality, safety, and efficiency in our current system. We have finite infrastructure, which means we have limited amount of tracks, limited amount of junctions and crossings. And due to our system having multiple train types such as suburban, local, freight, repairment, priority scheduling becomes a major key role to play with. Our section controller faces multiple challenges such as precedence, crossings, priority scheduling, and while maintaining the section characteristics like gradient, line capacity, signal placements, etc. Along with that, we have to keep in mind that the railway network currently in our country is extremely vast. It is dynamic and complex, and it is based upon a large scale. To minimize the challenges faced by the train controllers, we have developed an AI optimized system which minimizes congestion and maximizes throughput. We also have included a KPI dashboard which monitors the train traffic and an NLP chatbot which helps us give suggestion to the controller for better optimized system. Here's how our solution works step by step. For the first step, the AI models are trained on real-time and historical data for accurate delay prediction and priority setting, while the SCIP manages the constraints efficiently. In the second step, we have trained our throughput optimization model to maximize the section capacity and the rerouting model to reduce the overall travel time. In the third step, we have designed a what if simulator which helps the controller test out the rerouting and the platform allocation through efficient visualization. All of these models are connected securely to efficient and trusted API and secure website sources to make sure the data is secure and reliable. The controller portal is designed to be simple and intuitive with a built-in alert system. Together combined, all these features makes the system much more efficient than the existing manual one present in the system. Now let us talk about uniqueness and innovation. What makes our system truly stand out? Firstly, the what if simulator helps the controller predict out different types of outcomes for making the train reroute or halt, showing how the traffic would clear or build up depending on their situation. It helps the controller make much more secure, safer, hazard free, and quicker decisions in real time. Finally, real time adjustment. The current manual system falls apart on unpredictable delays. What happens when a system such as ours happens to come under such disruptions? We quickly reroute the trains, quickly reshuffle the priorities, and make sure that the system quickly responds to such sort of delays and disruptions on time.
Here is our simulation model, the multi-track train dispatch system powered by AI and machine learning. In this simulation, we are focusing on one platform at Ghaziabad station using both real and historical data sets. Whenever a train approaches the platform, our optimization engine predicts its delay, checks precedence, and decides the most efficient dispatch sequence. On the left, as you can see, the live platform status. In the center, the platform is marked as occupied, and on the right, the train queue shows all the upcoming arrivals. The AI engine continuously analyzes this data and gives real time advice to the controller using the options below: accept advice, ignore advice, or emergency dispatch. The controller stays in charge while the system supports them with optimized suggestions. As soon as the advice is accepted, the routing and dispatch model immediately clears the train, reducing congestion and maximizing throughput. This is how our AI powered solution ensures smarter, faster, and safer railway operations.
Now we proceed to the workflow. Data from timetables, signaling, and rolling stock enter the pipeline. AI model predict delays, prioritize train, and validate constraint via SCIP. Optimization model suggest reroutes or update schedules. Controller interact through the portal or NLP chat. Decisions are visualized via dashboard and what if simulator. Let's walk through our intelligent traffic management system. It is divided into four layers. First, at the base, we have input layer connecting real-time signaling, train timetables, rolling stock status, and TMS data. Second, this feeds into the processing layer where advanced AI model with reinforcement learning combined with the SCIP optimizer analyze the data. Third, based on this decision, layer drive key outcomes like throughput optimization, smart rerouting, and congestion management. Finally, the user layer empowers people. Controllers use a portal dashboard, provide real-time insights, a natural language chatbot simplify queries, and what if simulator lets teams test scenarios before acting. In short, it is a seamless pipeline from data to intelligent decision, deliver faster and smarter railway operations. Now we proceed to the tech stack we used. It starts with real-time input like signaling, timetables, and rolling stock. So AI with machine learning, deep learning, and reinforcement learning, plus the SCIP optimizer process this data to drive smart decision like rerouting, congestion management, and throughput optimization. User layer control, access it all through dashboard, KPIs, a portal, and a natural language chatbot with a what if simulator for testing scenarios. Tech stack. Behind the scene, it runs on Node.js, Express.js, MongoDB, and user secure API for integration. Docker contains with cloud and edge deployment ensure real time performance at scale. In just seconds, raw data becomes smarter, safer, and faster railway operations.
Now let us talk about the benefits of our platform. The NLP chatbot allows the controller to directly interact with the optimization engine where it can seamlessly ask their doubts through their friendly user interface. Secondly, the what if simulator ensures that we can have visual scenarios played for all sorts of delays and rerouting, which gives the controller much more hazard-free environment. Thirdly, the cost optimization comes through well-managed freight movements, which brings much more revenue to the already existing transit system. Along with that, we are also optimizing on the energy consumption through well-scheduled and well-rerouted plans on the current rail network. And lastly, let's talk about the social benefits. Due to reduced risks and well-planned system, the customers will have great experience with the railway network, building trust and safety.
Train management flow. The process begins login followed by collecting and integrating data from the train management system, signaling, rolling stock, infrastructure, and external disruption. This data is then proceed and model to build network graphs, constraint and train states. AI and machine learning submodel feeds into an optimization engine if multiple trains demand to same block or platform. The system checks for conflicts. A conflict-free plan moves directly to the controller dashboard, showing live maps, conflict areas, and a system recommendation. If conflicts remain overrides, and manual inputs are allowed before execution. This execution layer pushes decision to the live network, generating alerts, recommendations, and learning. Feedback performance is constantly monitored with the KPIs like average delay per trains, throughput, platform utilization, and on-time performance, helping the
Now let us look at the impacts of our platform on the current rail network. Firstly, our train precedence model ensures that the system will deliver much more smoother and efficient operations. Along with that, the dynamic train scheduling makes sure that the trains will reach on time and minimizes the hazards. The smart AI driven decisions make sure that there will be less congestion in the overall rail network. Due to these improved logistics, there will be much more revenue incoming in the current transit network. All of these qualities, all of these features ensure that there will be an elevation in the passenger experience in the complete rail network. Now, let us talk about the feasibility and viability and how we can integrate our solution into the existing Indian railways in a much more efficient and sustainable manner. Firstly, the AI chatbot and the AI driven system ensures that the controller gets much better and efficient solutions to the rerouting and delaying problems in the current system. Though it is not entirely making the decision, it acts as an assistant to the controller. This user friendly design makes sure that the platform is controller friendly. Now, secondly, we can talk about the scalability. Through cross zonal coordination and streamlined workflow, we are ensuring that the platform can be expanded pan India and used across the complete Indian rail network. Next comes the technical compatibility. AI is already being integrated into multiple transit systems worldwide, like Singapore, China, and all across the Europe. We are making sure that our software is well transitioning and well integrated into the current system without disrupting the already complex network. While our solution is quite powerful, these were some of the challenges we had to counter while developing the software. Firstly, the missing or the messy data. This inaccurate and unorganized data could have led us to have inaccurate AI results or wrong predictions. The second issue that we had to counter was the live data processing pressure. The real time data and the complex decision making can lead to heavy load on the computer system. And while developing these models, we also had to keep in mind how we will integrate these models into our current existing railway system. The system in itself is quite complex and has multiple things which we had to keep in mind while making sure that the models will be well integrated into the current system. Next, we had to counter the cybersecurity risks. We had to make sure that the system is protected from any sort of unauthorized access and there is a secure communication between systems. Our strategies are designed to convert our challenges into strengths. Through strong data handling, we use robust pipelines and fallback logics, ensuring accurate decisions even when inputs are inconsistent or inaccurate. We use fast decision making models, which give high performance cloud and edge computing, allowing our analyzing of data and suggesting optimal actions quickly, even under heavy load. We have seamless system integration where we use modular APIs and adaptable connectors, ensuring smooth communication with existing railway IT and signaling system. We are ensuring that security is kept first, where we are using end-to-end encryption, intrusion detection, and regular security audits, keeping critical data and operations safe at all times.
Looking ahead, the future scope of this system is both powerful and promising. First, enhance predictive analysis with leverage AI to forecast delays, maintenance requirement, and traffic pattern with far greater accuracy. Smart automation will further integrate with signaling, scheduling, enabling faster real-time decision making. At the same time, network-wide expansion will allow the system to scale across the entire railway network, ensuring consistent optimization everywhere. Finally, both passenger and freight will benefit, improving punctuality, reducing congestion, and creating a smoother, more efficient travel and transport experience. Together, these advancements pave the way for a smarter, more reliable, and future ready railway ecosystem.